with us, y'all. Okay, so I am recording, y'all. Before we do anything else, I sent you guys an email yesterday, or announcement at least, let you know that Monday, this coming Monday, is the last day to withdraw. So, y'all, I did um, update the grades in Gradebook. So if you go to Gradebook, and I don't know if it'll do it for me. I'm going to try something here, y'all. I'm going to try going to the student preview. Probably should have tried this before, but now it's me as a student. If I go to Gradebook here, okay, so my current grade is right there, right? Like that's me as a student, right? And does it have my grade's pretty bad, yeah. So like you can see my homework average is a 1.5. You can see I haven't done a ton of assignments, right? There's a ton of stuff here that I haven't done. So this is me as a student, right? Yeah, all this stuff here, you can see all this stuff is past due, that's been graded, right? So on and so forth. So again, y'all, that's me as a student. Okay, so let me try something here. Come back to content, and let me go ahead and exit this preview here because that's not what I want to do. I want to come back to the announcement. Okay, so again, you can check your grade in Gradebook, y'all, and if you're doing fine, then hey, you don't need to really worry about anything. And I hope nobody's in the red like I was. That's me as a student. But guys, this last day to withdraw, this is for any class in the 16-week semester. So this is not necessarily specific to my class, but any classes you're taking right now. So I was on Tuesday and Thursday, y'all, I have two other classes, so I kind of did the rundown with them yesterday, and I was telling them that, y'all, this applies again to any class. But if you need to withdraw from any class, again, I'm hoping you don't have to withdraw from any class, especially mine. But, if you got to drop, like, I don't know, your government class or your psychology course or whatever, my recommendation is, even though it's the last day to withdraw, do it on Monday. The college is kind of ridiculous in that if you decided today, Steve, you said you're taking a government class, right? So if I'm just going to make this up, so like if Steve decided today that he was going to withdraw from that government class, and Steve went over to admissions and said, "Yeah, I need to drop my government class," admissions would tell you you need to get permission from your instructor before you withdraw. And the reason I say that's ridiculous is, Steve, when you signed up for government, did you get permission from anybody? No, you didn't, right? You're an adult. You made that decision on your own. And so if I was a student, y'all, and the admissions told me you need to get permission, I'd tell admissions, look, I'm an adult. Either you help me or you can, or find somebody who will. Right? That would be my and I would tell them, look, I'm not trying to be rude to you, but I don't need anybody's permission. I'm a grown person, and whether I'm 48 or whether I'm 18, I'm a grown person, right? And I can make my decision. And so, guys, if you do it on Monday the 18th, they don't ever tell you you need permission. The reason they don't tell you that day, that is the last day to do it, right? So I was telling my students yesterday that if you tell this to your if you go to admissions and I've actually had people who've already messaged me through Chrono saying, "Sir, are you going to be around because I need to get permission?" All this kind of stuff. I'm like, just contact them Monday or tell them, look, I'm an adult. I don't need permission to do this. I'm going to bail in the class. That's what I want to do. If you do it, and the reason I was telling my students, y'all, do it on Mondays. Number one, you don't have to worry about that business. The other thing I was going to mention, and I'm going to pull this up here. I'm going to the STC website, and it's not on here, and I don't know why it's not on here, but it's not up here on one of these big, kind of slides. But if I go to the academic calendar, which is down here, and I go to spring 22, which is right here, and I kind of have to hunt for it. If you notice right here, April 14th, which is tomorrow, through Sunday, the college is officially closed. Okay, they call it the semester break. It always coincides with Easter, but they call it the semester break, right? So if you contact, your instructor and you're waiting for a response to them, if the college is closed, they're not we're not working either. You know what I mean? So I wouldn't want anybody waiting. Again, not necessarily for me, y'all, but like from any class. I don't want you guys waiting around like I'm still waiting to see if my teacher's going to approve. You're an adult. Just tell I'm going to go do this. So I don't want you guys, waiting around and then somebody says, well, my instructor didn't get back to me until Tuesday and Monday was the last day to withdraw, but I was waiting for them. You know what I mean? I think it's just a big mess. So that's why I say, if you're going to do it, just do it Monday. Nobody gives you a hassle, right? And there's the number for admissions right there. So, y'all, again, just a quick reminder, the college is officially closed tomorrow and Friday and Saturday and Sunday. So if you come over here, is the weight room going to be open? No. Is the tutoring lab going to be open? No. Everything is going to be closed, right? Because the college is what? They're closing everything, right? It's a holiday. You know what I mean? So just wanted to give you guys a heads up on that kind of stuff there. Okay. Guys, the other thing I was going to mention is because somebody asked me about this yesterday in one of my classes about withdrawing, and the question was, well, if I withdraw from a class, do I have to retake it? And the answer is maybe. If it's part of your degree plan, yeah, you got to retake it. You know what I mean? Like if you're going to major in government and you drop your government class, hey, that's part of your degree plan. Yeah, you got to take it. If it's one of those classes that's an elective, and there's some classes that are electives, and you can choose, like you can either take a psychology or sociology or, you know what I mean, something like that. And say you're taking psych and you drop psych, you have to repeat it? Not necessarily. Maybe you decide to take one of the other options. You know what I mean? Like maybe psychology wasn't for me. I'm going to try the sociology class, and you enjoy that class. Hey, you filled your elective. You know what I mean? So you don't necessarily have to repeat the class. You may need to. It just depends if it's required for your degree plan. All right. Last thing I want to tell you about dropping is, the state of Texas has this thing called the Rule of Six. The Rule of Six just says that in your academic career, as long as you're going to a public college in the state of Texas, so a public college or university, so whether you're going to STC or whether you're going to UT Austin or you're going to Texas State and San Marcos, or any public college. Okay, if you go to a private school, like if you decide to transfer to St. Edward's University in Austin, they're going to have a different set of rules. It might be the same rule, but they're going to have different rules because it's a private institution. But public colleges and universities have a rule of six. It just says that you cannot withdraw, or the limit for the number of withdrawals in your academic career is six, right? So if you drop six classes and then at some point you want to drop a seventh, college won't let you do it. They're going to say whatever grade you're earning is going to be the grade that you're going to get unless you change your grade or you know what I mean, like you make improvements or whatever. I'm sorry. You can retake the classes. Yeah, you just can't drop anymore after six. So y'all, when I was a student, I actually withdrew from two classes. I withdrew from a philosophy class that just was like way over my head. I didn't understand what was going on in there, and I actually withdrew from like this geometry class that I did not dig on at all. And I didn't have to repeat either of those because I took different classes. You know what I mean? Like I was minored in philosophy, but again, I could choose from a list. So I'm like, okay, Eastern philosophy, not my thing. I don't understand any of that stuff.
Philosophy, like Confucianism and stuff like that?
Yes, so I bailed on that class, and then I took like a different philosophy class. You know what I mean? And then the geometry class, again, it was an elective. So I was like, okay, I'll take a different math course. So I did that. So anyway, again, just wanted to give you guys a heads up, okay? But Monday the 18th is the last day to do it. My recommendation, y'all, and again, even if if you have like friends that are coming to here and they're thinking about withdrawing a class, just tell them, look, call on Monday. Nobody's going to give you a hard time. You know what I mean? If you have to bail, I hope nobody has to go. But in the event that you do, that's what you're going to do. Question?
I had to drop two classes. Well, not had to, but I chose to drop two classes in spring 2020 because that was the pandemic thing.
Yes.
And I didn't want to do those classes online.
Okay.
Will that still count towards the six?
Yes, because you withdrew. Yeah, I mean, why wouldn't it count towards the six? You know what I mean?
That's not what you paid for.
Yeah. Well, I mean, are there going to be, is the state making exceptions? I don't know, John, but I would say that's part of the six. You know what I mean? That's part of the six. Okay, so anyway, y'all, just wanted to go through that stuff. Let's see. Today, what are we doing? We're going to go through 5.5. Okay, so 5.5 is what we're doing today, y'all. By the way, y'all, I did upload the lectures already for 5.2 and 5.3. I think I did it late Monday. And I'll upload 5.5 this afternoon as well. Okay, I'll get it done before the day's up. Let's see. So let me come back over here. Here we go. So let's see what we're doing today, y'all. Today we are covering something called substitution. Okay. Substitution is, we're going to use substitution to evaluate what we call indefinite integrals. We've talked about those before, and definite integrals. Okay, so it says, theorem 5.7 says, substitution with indefinite integrals. Let u be equal to g of x, where g prime of x is continuous over an interval, and let f of x be continuous over the corresponding range of g. Let capital F of x be an antiderivative of f of x, then the integral of f of g of x times the derivative of g of x is equal to f of u du. Okay, let me explain what I'm talking about here. There's an easy way, hopefully an easy way to understand the process and what we're doing with substitution. Okay, so I'm going to just kind of start y'all with the first problem that I have right here. It says evaluate the integral, and we're integrating the quantity 2x plus 4 times x squared plus 4x plus 2 all raised to the fifth dx. Okay, so we know how to find antiderivatives. The issue that we have right now, y'all, is we have no idea how to find the antiderivative of something so complex, right? Because look what this thing is. It's being raised to what power? To the fifth, right? So if we were to write this thing down 5 times and multiply it, and then distribute the 2x plus 4, then we could find the antiderivative of each of those individual pieces. But the way it's written like this, like we wouldn't be able to do it. So the instructions here tell me, look, we're going to make a substitution. We're going to let u be equal to x squared plus 4x plus 2. So, y'all, I got a question for you. If u is equal to x squared plus 4x plus 2, then wouldn't du dx, meaning I'm taking the derivative of u with respect to x, what would the derivative of this expression here be? We're taking the derivative, not the integral, not the antiderivative, but the derivative like we started back in chapter 3. 2x plus 4. Okay, so y'all, what I'm going to do now, I'm going to bring this factor of this dx, I'm going to move it over to the other side. So this is going to give me du equals 2x plus 4 in parentheses with my dx. Okay? All right. So what I'm going to do now, y'all, I'm going to try to rewrite the problem that we have. Okay? We're going to write the integral. I want you to notice this piece right here, isn't that x squared plus 4x plus 2? Didn't we start off by calling that what letter? Okay. And it's u, and it's not just u, but it's u to what power? To the fifth. Okay. Now, I want you to notice this piece right here. Do you see how I have this 2x plus 4 with that dx right there? I want you to look at this part. I got a 2x plus 4 with a dx right there, right? Isn't that the same thing as what? The du, the derivative of u? Okay. Now, I want you to take a look at what I have now. Now I have an integral. I'm not dealing with the variable x anymore. I'm now dealing with the variable u. And we want to find the antiderivative of this u to the fifth with respect to u. So now we can use our antiderivative properties, right? Remember, when I want to find the antiderivative of u to the fifth, do you remember what we do with the exponent? We have to add how much? Okay, so it's going to be u to the sixth divided by 6, okay? And then remember, plus that constant of integration plus the c, okay? All right, we're almost done here, y'all. One last step. We're now going to go back and resubstitute. U, we started off by saying u was x squared plus 4x plus 2. So right here, I'm going to rewrite that as an x squared plus 4x plus 2 over 6. That is still being raised to the 6 plus c. And now we were able to integrate the original function that we had, or the original expression. We're able to integrate it in terms of x, because we did this kind of a substitution. So that's the idea here. We're going to be doing this kind of substitution. And y'all, I'm going to write something down right here. I'm going to go ahead and write my answer in here. So we had, what was it, x squared plus 4x plus 2 to the power of 6, all divided by 6. Yo, I want you to understand, or when you're doing your homework, they already have the little plus c on the outside, so you don't have to worry about writing the plus c. But remember, there's always that constant of integration, right? Because if we would have had a plus 2 on the end, we took the derivative, we'd end up with the same thing, right? So the idea behind this substitution, y'all, and again, I know for a lot of y'all, it's probably been a while since y'all had college algebra. But the only reason I'm bringing this up, y'all, is because I was doing this last night in my college algebra class, not this problem, obviously, but the idea of substitution. So one thing I was telling my college algebra class last night was, like, if I was going to solve this problem here, I'm going to make this up. If I was going to solve x squared, let me see, plus 6, let's go like this. If I was going to solve this problem here, right, I could do it by factoring and all that kind of good stuff. And in my college algebra class, y'all, earlier in the semester, we did problems that looked like this. X to the 4th minus 5x squared plus 6 equals 0. And I told them, look, if you know how to do this problem here, we can essentially do the same problem here. Because I want you to notice, instead of an x, now I have a what? An x squared, right? And instead of an x squared, now I have a x to the 4th, right? So I told my college algebra class, I said, look, y'all, we did this back earlier in the semester. And I said, when we did these problems, we would say, look, let's u be equal to always the middle piece, which was x squared. So then u squared was really x to the 4th. And then now what we would do is we'd say, look, instead of me writing an x to the 4th, I would write a u squared. Instead of me writing an x squared, I would now write a u, and then a plus 6 equals 0. And then I can just factor this problem because I can do this problem the same way we did that one. And I told them, okay, do y'all remember what two numbers multiply to 6 but add up to a negative 5? Okay, remember, they need to multiply to positive 6 and add up to a negative 5. Anybody know? I'm sorry, say it again? But they have to multiply to positive 6. So guys, 3 and 2, right? Negative 3, very good. Negative 3 and negative 2. If you multiply them together, you get a positive 6, and if you add them, there's your negative 5. And then we're going to get u equals 3, and we're going to get u equals 2. But this problem, we were trying to solve it for the letter x. So then now all we would do is we'd say, look, x squared equals 3, and x squared equals 2, and then we can take the square root on both sides, and we get our answers, right? So we did these kind of problems back in the day, y'all, and even if it's been a really long time since you've done college algebra, you probably at some point did something similar to this. So the idea is, just like the way we would solve these problems by introducing, we call it a dummy variable, it's just like bringing in a new letter. With this substitution, that's kind of what we're going to be doing with the problems that we have here in 5.5. We're going to let u be one of the expressions that we have, and then we're going to try to integrate with respect to u, and then go back and plug in what u is equal to so we can solve in terms of x, okay? So look, let me come back to my problem over here. And again, y'all, I want y'all to understand something just for a second. Let me clean this mess up. So when we were doing this problem right here, we were integrating with respect to what letter? With respect to x, and if you notice, my answer is in terms of x, right? But we had to do that initial substitution to do this, okay? Questions?
So how do we go from the integration integral with respect to the
Because if I'm trying to integrate this part right here, don't we say, what do I need to do with my exponent? Oh, add 1 to it, and then divide by that number. So if all I'm integrating is u to the 5th, I'm just using my power rule, right? The power rule says add 1 to your exponent and divide by that same number. Make sense? Yeah. Okay, so look, y'all. In going through the little steps here, it says look carefully at the integrand. The integrand is this business right here. And select an expression g of x within the integrand to set equal to u. Let's select g of x such that g prime of x is also part of the integrand. Okay, so let me explain what they're telling me here. if you notice in this problem, they already told me what to use for u. So here's my u, but when I take the derivative of u, look what we end up with, and isn't that part of that inside tube? That's what in essence they're telling me to do. And then it says, now we should be able to evaluate the integral with respect to u, and then we come back, and then we do it, and then we come back and do that, plug it in so we can find the x value, okay? So look, we're gonna do the same type of process through some of these problems here. And y'all, again, these problems I took directly from your homework. For the first few problems, they're gonna tell you exactly what to use for u. And then other problems, they don't, and we gotta figure that part out, okay? But we're gonna go through the process here. Hopefully it makes sense. So first thing, look what they're telling me. U is gonna be equal to x to the fourth minus one, okay? So y'all, if I take the derivative of u with respect to x, what is the derivative of x to the fourth minus 1? 4x to the third, right? 4x to the third. Okay, y'all, just like we did before, I'm going to bring this dx over to the other side. So we have du equals 4x to the third dx, okay? Now, I want y'all to notice something here. Isn't what I have inside my parentheses, isn't that my u? Okay. Now, look at the other part we have. The other part we have is we have an x to the third and a dx. Well, that looks a lot like this piece right here, doesn't it? The only thing is I have an additional number in front. What number do we have in front? We got the 4. Okay, so let's do this. Let's divide both sides by 4, or multiply it by 1/4. Okay, so those 4s are going to go away. So now I have a 1/4 du is equal to an x to the third dx. Okay.
Okay.
All right, so now I want you to notice something. Look, I'm going to integrate. This piece right here, this x to the fourth minus 1, hey, that's what we call u. So I'm going to write a u there. It's to the power 43. This x to the third and that dx is right here. So I'm going to bring in my du, and I'm going to keep that 1/4 on the outside, because if I have a constant, I can always carry that constant outdoors. Okay. All right. So now we should be able to find the antiderivative of u to the 43rd power. So I'm going to give you a hint. I'm still going to have my 1/4. What power am I going to have now if I'm finding the antiderivative of u to the 43rd? It should be divided by, okay, plus c. Okay, we're almost there. Question, y'all. Anybody know what's 4 times 44?
4 times 44?
4 times 44.
176.
176, okay, plus c. Okay. Last step, y'all. The last step, what we're going to do now is we are going to take the value, what we started off with. We're going to take this value of u, we're going to plug it in right there. So that's going to give me x to the fourth minus 1, all raised to the power 44, divided by 176. And here's my plus c. Again, y'all, just a quick reminder, when you're going to plug in your answer in MyOpenMath, they already have the little plus c at the end, right? So all you're going to do is go x to the fourth minus 1 over to the power 44 over 176, because they already have the little plus c out there. Is it making a little bit of sense as we're going through it on how to do this kind of substitution a little bit? Okay, guys, and all we're doing today is this one section, just 5.5. And I have, like, I don't know, there's something like 11 problems or 12 problems in there. I'm hoping that as we go through them, it gets a little bit better, okay? So let's see. Let's take a look-see at the next one. Okay, and again, I'm going to go really slow here, y'all. And the one thing I really want to emphasize, y'all, is, again, notice I took these problems, y'all, directly from the homework. So they're telling me exactly what to use for my substitution, okay? So let's get started and let's see what we're going to do. It says let u be equal to 2x, okay? So that's my step number one. My step number two is I'm going to find du dx. What is the derivative of 2x with respect to x? 2, okay? Step number three, y'all, I'm going to move that dx over there. So I have a du equals a 2 dx. Okay. Step number four, I'm going to rewrite this problem using the letter u. So look, we're finding the antiderivative of secant of, what did we call 2x? We called it u. Tangent of, what did we call 2x again? U. Okay. Now, I wanted to show y'all something. Look, y'all, right here, I just have a dx. In my step number three, look, here's that dx, right? I want to get this dx by itself because I want to make it look, this piece looking exactly like that one. If we divided both sides by 2, wouldn't we have 1/2 du is equal to dx? Okay. Now, what I'm going to do here, y'all, I'm going to go ahead and write in my du, but since I have that 1/2, that 1/2, y'all, is just going to come out to the front. Okay. All right. Now, it's been a little while. I'm going to be the first to admit it's been a little while. Does anybody remember the antiderivative of secant u tangent u? So what do I have to take the derivative of so that I get secant u tangent u? Anybody remember? So I'll tell you what, let's do this, y'all. So look, I'm going to come back over here. Let's see, where is it? Formula sheets and chapter notes. And I don't know if it was in the formula sheet for test one, but I'm going to check. It could be. Let's see. I'm just scrolling until I find some trig stuff. Okay. Here we go. Okay. Take a look right here, y'all. The derivative of secant x is what? Secant x tangent x, right? So that means that the antiderivative of secant x tangent x would just be secant x, right? Does that make sense? Okay. So look, let's come back over here. And my question to you all now is, look, I still have that 1/2. What is the antiderivative of secant u tangent u? Secant u. Okay, it's all about u. And then we've got one last step, y'all. Last step says we're gonna come back and we're gonna resubstitute. Where the u used to be, we're gonna write it as a 2x plus my constant of integration, right? Again, y'all, just a quick reminder. In my open math, they're already doing us a favor. They're putting that plus c at the end. So right here in my box, I'm just going to write 1/2 secant of 2x because the plus c is already written there for me. Does that make a little bit more sense? Better? Okay, so y'all, this is going to be my process every single time, okay? There should be something, again, with these first few problems, they're really generous and because they're telling us, hey, look, start off with u equals this, right? They're generous in these first few problems. At some point, they're not going to be as generous, and we're going to have to figure out what we're going to let u be equal to, but hopefully we're able to figure this out from here, okay? So first thing I want y'all to notice in this problem, y'all, they did not tell me, hey, let u be equal to this, right? Like they didn't, no favors here at all. That's okay. First thing I'm going to do, y'all, I'm going to rewrite this. I'm going to bring the 9 outside. And this is sine to the 5th x cosine of x dx. Okay. What I want to do here, y'all, is I want to look at these pieces. And I want to ask myself, would the derivative of one of those functions give me the other one? And y'all, the easiest way to think about it is don't worry right now about the power. Think about it without the power. So if we were to say, like, suppose we were to say, look, let u of x be sine of x, then wouldn't du dx, what's the derivative of sine? Cosine x, right? And again, if I bring that dx over, look what we have. We have the cosine of x with the dx, right? Isn't this piece right here, y'all, the same thing as my du? So look, I'm going to leave that 9 out there because we already had it. Now, if u is equal to the sine of x, then the sine of the fifth, wouldn't that be u to the fifth? So, y'all, one thing I really want to emphasize is when I see something like this, another way that I can write it, and it probably seems easier to think about it like this way, sine to the fifth really means sine of x all raised to the fifth power. Yeah, I'm not raising the x to the fifth power, I'm raising the sine function to the fifth power, okay? So just to give you a heads up, let me write it over here on the slide just so that you know. If you see something like this, I'm gonna clean this up and make it look a little bit better. If you see something like sine to the, I don't know, let's go r x, okay? That's the same thing as sine to the x all raised to the power r, okay? Just so that we know. And again, I know sometimes it looks a little odd, like, hold on, what am I raising to the power? I'm raising the whole thing, okay? Not the angle, but the whole thing. Okay, so now, if this is sine x and all of that to the fifth, isn't this really the same thing as u? So that would be u to the fifth. This cosine of x dx, hey, that's the same thing as my du, right? Okay, so look, we're almost done. I'm going to leave my 9 there because it's part of my problem. Does anybody know what is the antiderivative of u to the fifth? U to the sixth divided by 6, and then very good, plus our constant of integration, c. Okay. So we're going to do 2 things now. Number 1, can we not reduce the 9 and the 6? Yeah, so look, this is going to be a 3 over 2, right? What did we say u is equal to? U is equal to what? Yeah, so can I write it like this? It's now sine to the 6th power of x because it was u to the 6th. And my plus c. And then again, y'all, when I come back to write my answer, notice, here's the plus c. Oh, look, they were nice. They left that. So all I'm going to do here, y'all, is put 3 halves sine to the power of 6 over x. Again, y'all, if you want to, if it's better for you, you can put this in parentheses and raise it to the 6 like that. They both mean the same thing. Okay, they both mean the same thing. Which way is better? Whichever way you want to write it.
Where does the du go then? Why does it disappear?
Because, okay, so I have to change this part here to my du because my variable is now what? Because this here tells me I'm finding the antiderivative with respect to what letter? With respect to u. So just like the way this little, just like the way that little symbol disappeared, that disappears too because we found the antiderivative. Does that make sense? Good, good, good. Yeah, no, it's just letting you know that you're taking the antiderivative with respect to u. Yeah. So y'all, for these, there's actually 1, 2. These next 2 problems, I kind of probably should have put these at the beginning, but I think now that we've done a couple, this part's probably going to be pretty easy to do. But we're going to do the same thing here. So again, we're going to look at our problem here. Notice they're asking me, okay, what should I let my u be equal to? So again, what I want to do here, y'all, is I'm going to look at this piece here, and I'm going to look at this piece right here. The idea is you want to let your u be some kind of expression so that when you take the derivative of u, you're left with something that looks like whatever you might have left over, What I mean by that is, if I look at this problem here, and I said, look, let me look at what I have on the inside. If I let that be equal to my u, and I now take the derivative of u with respect to x, what's the derivative of x to the 6 minus 1? Wouldn't it be 6x5, right? And then if I bring that dx over, we have a 6x5 with a dx, right? And y'all, now if I do a little stare and compare, look, here's my x5 and here's my dx. Here's my x5 and here's my dx. So wouldn't 1/6 of du be equal to x to the 5th and dx? That's sort of the idea. You're going to let your function u be something so that when you take the derivative, you have something that's similar to that. If it's exactly the same, hey, great. And if it's not exactly the same, hopefully we can like morph it into something that looks the same. Does that make sense? Okay. So look, y'all, this is what we're going to do. We're going to come back over here. And the problem's saying, okay, what should we let u be equal to? Oh, we're going to let u be equal to x to the 6 minus 1, right? And what is du equal to? It's not asking for 1/6 du, it's asking for du. Well, du is 6x to the 5th. Look, they already had the little dx there, so I don't got to worry about writing that part out, okay? But now we do want to figure out how would I write this integral. So look, we're going to go like this. The integral is going to be, if this is the 5th root of x to the 6 minus 1, but we're saying that x to the 6 minus 1 is the same thing as u, wouldn't that be the 5th root of u? So far, so good? Okay, and then this x to the 5th and that dx, it's right here. Isn't that going to be 1/6 du? Okay. Now, y'all, one thing I want you to notice, look, they're asking me, what should I write here inside this little box? Well, I took the constant outside because, you know, when you have a constant, you can always bring it outside. But notice, they don't have it outside. So I would just bring it back inside here. You know what I mean? And that's all that I'm going to write. Okay, I'm always taking that constant out because it's just going to be an additional factor that I'm going to have when I actually integrate it. But y'all, for this problem, you're actually dumb. They don't actually want me to solve it anymore. That's all they're asking me to do is just kind of plug that in. So this, I probably should have put this problem at the beginning because this is more of like, how would you set it up? You know what I mean? But we've actually already done a few. So for this problem, y'all, and the next one, that's really all they are. They're just kind of like, how do you set it up? Okay.
Can you just, is it possible to rewrite it and just have it that way?
What do you mean?
Have that.
Oh yeah, you can write it divided by 6 if you want to. It's the same thing, right? It's just personal preference. You want to write a fraction? Write a fraction. You want to write it as a constant in front? Write it as a constant in front. Okay. So look, y'all, let's see if we can do the same thing here. So again, I'm going to go really, really slow. And remember, whatever my u function is going to be, I want to pick my u function so that when I take the derivative of it, it looks like something else I would be left with. So I got a question for you guys. What do you think we should let our u be equal to here? X to the 5th plus 5, right? Does that sound good? Okay, so that's going to be my u function. So remember, that's my step number 1. My step number 2, y'all, is for me to find the derivative of u with respect to x. So what would du dx be? 5x to the 4th. So doesn't that mean that my du would be 5x to the 4th with the dx? Okay, so look, y'all, I'm going to stop there for right now, simply for the reason that step number 1 is saying, what is my u? Hey, we said u was x to the 5th plus 5. Step number 2 is saying, what is my du? Well, hey, our du is a 5x to the 4th. Again, they were nice enough already that they already wrote down the dx. Okay, now we're going to see if we can write the integral. Okay, let's take a look here, y'all. Let's see. This piece right here looks very much like that part, doesn't it? So if we were to multiply both sides by 1/5, wouldn't 1/5 du be equal to x to the fourth dx? If we were to divide both sides by 5 or multiply by a fifth. So now I can say, look, this piece along with this is my 1/5 du. So look, I'm going to write it out. So I'm going to put my 1/5 right here. And x to the fourth dx is the same thing as my du. And on the bottom, what were we letting x to the fifth plus 5 be equal to? Didn't we call that what letter? Okay, so isn't that u, but to what power though? To the fifth. Okay. And that's what we're going to have right here. We're going to have 1 over 5 u to the fifth. Okay. So, y'all, for a lot of these problems, I think the big portion of it is it's almost like a little game. Can you figure out what your u would be so that when you take the derivative of u, it's something like what you already have written in that expression? Okay. As we. The integral. So we started off with u equals x to the fifth plus 5, right? So remember, the game here is, it's hard for me to integrate something like this, right? Because it has so many components. So what we say is, look, we're gonna try to simplify it. We're always gonna let our u be equal to something in this portion here, right? Something in either this part or that part, so that when I take the derivative of it, I'm left with the other portion. So what I mean by that is, like, if I let my u be equal to this part, then when we take the du, we get 5x to the fourth. Well, look, there's that x to the fourth, right? That's how we kind of want to pick our u. And then again, if you notice, we had an x to the fourth and a dx. Well, that's exactly what we had right here. So if I divide both sides by 5 or multiply by 1/5, I get 1/5 du equals that x to the fourth dx. So this thing right here is the same thing as my 1/5 du. So when I was doing my problem, this is how I kind of started off with it. I said, look, we're going to integrate. X to the fourth dx is the same thing as 1/5 du, isn't it? Now, down here, we have that x to the fifth plus 5. So on the bottom, I'm going to put, instead of an x to the fifth plus 5, I'm going to write it as a u, but the whole thing is being raised to the fifth power. Does that make more sense? Yeah. And now we can find if we needed to find the antiderivative or the integral, we could then do that, right? But for these problems, y'all, for these two here, it's just kind of setting it up. You don't actually have to do any more. You can just stop right there, right? So again, this right here is the same thing that we have right there, right? All right, so look, y'all, I'm going to kind of keep trucking along here. And so again, this problem here is asking me to find, evaluate the integral, and then we're actually going to figure it out in a second, okay? So, first question, what do you guys think we should let our u be equal to? Okay, x to the fifth minus 5. Good. Step number 1. Look, y'all, step number 2, we're going to find the derivative of u with respect to x. So the derivative of u with respect to x, everybody agree it's going to be 5x to the fourth? Okay, step number 3, let's move the dx over. Okay. Step number 4, I want to do a stare and compare. I want to look at what I have here and see if I can match up some of those pieces over here. So look, y'all, right here, I have an x to the fourth and I have a dx. Look, I have an x to the fourth and I have a dx. So my step number 4 is going to say, look, 1/5 of du would be x to the fourth and dx, wouldn't it? Okay. All right. Now, guys, I'm going to just kind of keep writing here. I'll come back and I'll fill in the blanks in terms of my actual problem in a second, okay? Look, step number 5, we're going to integrate. Okay, so this x to the 4th and that dx, we call that a 1/5 du. I'm going to leave the 1/5 on the outside. I'm going to put my du right there, okay? Now, this x to the 5th minus 5, didn't we start off by calling that what letter? So that's going to be a u, but what power do we have? 15. Okay. So now, y'all, now we're going to go ahead and find the antiderivative. Jennifer, am I doing okay? Did I lose you? Oh, well, because remember, when we're integrating, do you see how the dx always kind of comes at the end? That's why I kind of have my du out there, right? So the way I started off there, Jennifer, was I came back to this problem and I said, look, here's my x to the 4th and here's my dx. So here's my x to the 4th, and that's my 1/5 du. So the 1/5, I just kept it there, and I just kept the du at the end. And then now we said, look, our u was x to the 5th minus 5. So this here is going to be u, but to the power of 15. Okay? Now, y'all, we're going to go step number 6. Step number 6, we're actually going to integrate it. We're going to find the antiderivative. Y'all, since we have that 1/5, I don't want to forget it. I'm going to write it down. Okay, question. Does anybody know the antiderivative of u to the power 15? Okay, very good, right there. Plus c. Okay. Y'all, step number 7, distribute. So this is going to be u to the power 16 over 5 times 16. Anybody know? 80. Okay, and then finally, step number 8, we're just going to go back and resubstitute. What did we start off letting u be equal to? Yeah, x to the 5th minus 5. So look right here, y'all. We're going to have x to the 5th minus 5 to the power 16 over 80 plus c. Okay. Let me zoom out a little bit so we can see everything on there. Okay, so now that we've actually solved the problem, all I'm going to do now, y'all, I'm going to come back and I'm going to fill in the blanks. Look what the first blank says. By making the appropriate substitution, u is equal to, what do we say u is equal to? That's all we're going to do, x to the 5th minus 5. And when we integrated this thing, so after we got through with doing everything, what answer did we come up with? That piece right there. Y'all, on this problem, they were not so nice to me because they did not include the what. Yeah, so I don't want to forget the plus c right there. Okay. Oh, yeah, 5, sorry, not 15. My bad. There you go. And an 80 on the bottom, right? What am I coming up with these numbers? Just making up stuff today, right? What's today? Sunday? Yeah. Before this, the day before the semester break, yeah. And my brain feels swollen already. What are you going to reduce? Okay, no, you can't do it that way. What does it mean to raise it to the 16th power?
Yeah,
You got to write it down how many times? Yeah. Not today, not on Sunday. Yeah, that's all you're doing there, right? That's all you're doing there.
15,650,780.
Yeah, way too much, right? Way too much. How many more do we have? 1, 2, 3, 4, 5, 6, 7. 7 more. Okay. But again, the one thing I want to emphasize here, y'all, all these problems here, I'm going to do them exactly the same way. Okay. This is, I'll tell you that to me, 5.5, I actually enjoy this section because I know how to find antiderivatives. And all I'm doing is kind of like trying to manipulate, trying to like match stuff up. You know what I mean? Like, how can I fix it so it looks like a problem that I know how to do? So, y'all, you ever heard that story? How do you kill a blue elephant with a blue elephant gun? And how do you kill a pink elephant? No, there's no such thing as a pink elephant gun. You take that pink elephant, you squeeze it till it turns blue, and then you shoot him with a blue elephant. Right?
I've never.
You ever heard that before? No. So
Psychopath doing that?
so I have an uncle. He's all about jokes, and he used to tell that to us when we were little kids. But he was like the moral of the story is if you don't know how to do something, try to make it look like something you know how to do, and then the idea is okay, now I can do it. You know what I mean? So that's really what we're trying to do with these problems. We're trying to make these problems look like something I know how to do because like when I look at this problem here, y'all, like I have no idea how to do this problem, right? So the first step is going to be, okay, what are we going to let our u be equal to? So y'all, we don't have a lot of choices here. What do you think my u is going to be? 8x plus 3, right? Okay, good. Step number 2, let's find our du dx. Okay, du dx, what's the derivative of 8x plus 3? 8. Okay, step number 3, let's move the dx over. So du equals 8 dx. Okay. Look, y'all, I'm going to show you something here. I don't have an 8 dx, but I do have a dx, right? So wouldn't my step number 4 be 1/4 of du is equal to dx? Or 1/8, I'm sorry. Yeah, sorry. And I'm still thinking about that blue elephant gun. Okay, 1/8 du is equal to dx. Okay, step number 5, y'all. And again, I'll come back and I'll fill in these blanks at the end. Step number 5, I'm going to say, look, this dx here is the same thing as 1/8 du. So I'm going to bring the 1/8 out. I'm going to leave my du at the end because we're going to be integrating with respect to u. Now, y'all agree that the number right here in front really is a 1? So I'm going to put a 1 here. Now, my 8x plus 3, wasn't that really the same thing as our... So isn't that going to be u squared? Okay. Step number 6, y'all. I'm still integrating here. I want to rewrite this part so that it has like a power that's negative because it's easier for us to do it that way. So couldn't we do this? And then now we can go ahead and apply our power rule. So remember, what are we going to do with this exponent here? We need to add how much to it? We need to add 1. So look, step number 7, we're going to have 1/8. Okay, if we add 1 to it, everybody agree u to the negative 1? Divided by negative 1, right? Okay, plus what? Plus c. Okay, don't forget the little plus c. Okay, we're almost done, y'all. Got middle. Step number 9, look, we're going to go really slow here. If it's 1/8 if it's 1 divided by 8 and u to the negative 1 over negative 1, isn't this really like a negative? I can think of the negative here, an 8 on the bottom, right? Can I think of that u as being downstairs? Because it's a negative exponent, won't it have to move to the bottom? And don't I still have a... Oh, 9. Sorry. Man, telling you guys, I need a semester break. All right, sorry about that. Okay, so look, 1/8 right here. Here's my negative. I just kept the negative on the top. Brought my u down, okay, plus c. Here's my step number 9. There it is. Okay, last step, y'all. Take a look. Negative 1/8 times, what did we say our u was? Right here. 8x plus 3. And then at the very end, plus c. Okay. Yes. So step 7, remember when I'm going to integrate this thing? We need to add 1 to the exponent, right? So if I add 1 to negative 2, doesn't that give me a negative 1? And then don't I have to divide by that same number? So remember, when we're integrating, let me come back over here. What was it? Here we go. When we were integrating this one here, Jennifer, didn't we say, look, we're going to add 1 to the exponent? So that gave me a 16. And then didn't we also divide by 16? So look, when I come back over here, I know when it's dealing with negative powers, it kind of throws us off. But if I have a negative 2, I'm going to add 1 to it, so that gives me a negative 1, and then I have to divide by that same number, right? Yes. So now, this negative, I'm just saying, look, let me bring the negative up to the top, -1. The 8 still on the bottom. Since this u is to a power -1, can't we bring it downstairs? And then our plus c? Okay. Yeah. Yeah, no, we're good. We're good. Okay, yo, so look, we solved the problem. Now all I'm going to do is I'm going to come back and fill in the little blanks it's asking me to fill in. Let's see, the first one. What did we let our u be equal to? 8x plus 3. Okay. And when we finally took the antiderivative, when we finally integrated all that stuff, didn't we end up with a negative 1 over 8 times 8x plus 3 plus c? And that's all I'm going to enter in right there.
I can do that.
Yeah, you want to? Go ahead. Okay. So again, with all these problems, this is going to be my process, is trying to figure out how can I start off, what can I let my u be equal to so that when I take the derivative of it, it looks like something that I already have. Okay. So look, we scroll through the next one, and again, we'll do the same sort of process that we have here. Okay, so step number 1, what is our u going to be equal to? 9 plus x to the third. Okay, step number 2, what is my du dx? Very good, 3x to the second. Okay, step number 3, let's move our dx. So 3x to the second dx, right? Okay. Step number 4, multiply everything by 1/3. So 1/3 du equals x squared dx. And again, why do we want to do that? Because here's my x squared and here is my dx, right? We divided by 3, but isn't that the same thing as multiplying by 1/3? Yeah. Okay, so think about it this way. Dividing by 3, think this way, Jennifer. When you have a fraction means you're multiplying by the top number and dividing by the bottom. So if you said we're going to divide by 3, okay, we multiply by 1, well, still same number, right? And then dividing it by 3. Okay, look, y'all. So now we're going to come back over here. We're going to see if we can't figure out how to integrate this thing. So look, step number 5. My x squared dx is right here, and that's the same thing as 1/3 du. So I'm going to put a 1/3 here. I'm going to put my du. The square root of 9, I'm sorry, the 9 plus x to the third, isn't that the same thing as our u? So can we write that as u to the power 1/2? Because isn't that really what the square root means? Okay. So now, y'all, again, notice my du was the x squared dx. So those went away because we were able to replace it with the 1/3 and the du. The 9 plus x to the third was our u. Since it's the square root, we wrote it as the power 1/2. Okay. All right. So now, step number 6. I'm going to leave my 1/3 as it is. Remember, we need to add 1 to that power. What is 1 plus 1/2? 3/2. And we're going to divide by that same number. But dividing by 3/2 is the same thing as multiplying by how much? Multiplying by 2/3, isn't it? Because if I'm dividing by 3/2, I'm multiplying it by the reciprocal, right? Y'all don't forget my plus c. Okay. Okay. Step number 7, we're going to go back and resubstitute. Okay, first off, 1/2, 1/3 times 2/3 should be something like 2 over 9. Okay, what did we say u is equal to from the very beginning? 9 plus what? X to the third? And all of that is being raised to what power? There you go. Okay, so y'all, right here, what I'm going to do in my answer box, I'm going to write 2 9. 9 plus x to the third to the power of 3 halves. Hey, there's that plus c. They left it there. Okay, so remember, when I'm integrating, remember with this exponent right here, Brittany, what I need to do is I have to add 1 to it, right? So if I have 1/2 plus 1, can I think of that as 1/2 plus 2 over 2, which is 3 halves? And then, so that's going to be my 3 halves right here. And then I need to divide by that same number. But if you divide by a fraction, it's the same thing as multiplying by the reciprocal. Is that better?
Reciprocal is a fraction plus.
There you go.
Numerator and denominator.
There you go. Good, good. Y'all, I really want to emphasize that what I'm looking for here, or what we're trying to do here in 5.5, y'all, is recognize a pattern, and then there's just like multiple steps that we need to take so that we can transform what we have right here into something that's more manageable, right? Something that's more manageable, something that I can find the antiderivative hopefully a little bit easier.
I know people like this, but in the real world, our calculator can just actually just straight up solve the problem.
Yes.
So
Yeah.
there would be no need to do this. We do this by having to learn how to do more complicated.
How to do more complicated problems, and it's like a training sort of process, right? Okay, so look, y'all, we're going to do something here. We're going to take a look at this next problem. We're going to try to see if we can figure out some parts. Let's see. First off, what do you think we should let our u be equal to? X plus 5. It's always going to kind of think about it this way, y'all. In these problems, we kind of have something that we call like inside functions. What I mean by inside functions, that is inside the square root, right? Same thing here. That was inside the square root. The one that we did earlier, that was inside the denominator. You know what I mean? So think about your u being this kind of like the inside function. Okay, so hold on. We'll get there in a second. So look, here is my u is equal to x plus 5. Y'all, question. What is my du? That's my next step number 1. Step number 2. What is my du dx? 1. Okay, step number 3. Isn't du, if I move that over, just going to be dx? Okay. So we're going to do a couple of things here, y'all. When I'm looking at integrating this function here, I know we have a 4. I'm going to bring the 4 on the outside. This piece right here, isn't that really my u? Okay, so this is u. Square root means what power? 1/2. Okay. Now, I want to show you guys something. I know that I still have that x there. If I look at this u equals x plus 5, if I were to solve this equation for the letter x, do you guys agree that u minus 5 would be equal to x? Okay. If I were to solve this equation here for the letter x, if I were to move the 5 that way, do you agree that u minus 5 would be equal to x? Okay. Now, the reason why I want us to do that, y'all, is when I'm going to integrate this in here, look, this is my step. Let me get rid of this. Write it over here. My step number 4 is going to say, look, I know I have another 4 here, y'all. I don't want you to think I'm writing the 4 twice. It's just, there's that 4 right there. X was the same thing as u to the u minus 5. So I'm going to write a u minus 5. Okay. The square root of x plus 5 is really the same thing as the square root of u, or u raised to the power 1/2. And my du and my dx are actually the same thing. Okay. Before I go on, are we making sense on how we got to where we are? Okay, so again, just a quick recap here, y'all. The 4 came outdoors. That x, I replaced it with this u minus 5. The square root of u minus 5, the square root of x plus 5 is the same thing as the square root of u, which is really u to the power 1/2. Okay, and then my du is the same thing as my dx.
So,
So before I go on, are we okay in how I got to this step right here? Yeah, we're good? Okay, yo, this is what I'm gonna do now. We're gonna do some distributing, okay? So look, here's a 4 right here. The power on this u is really a 1. Y'all, if you remember, when you multiply variables, what you do with the exponents is you add the exponents together. What is 1 plus a half? 3 halves, right? Minus 5 to the power 1 half. Okay. Du. Okay. Now, we should be able to find the antiderivatives here. Look, y'all, I still got this big 4 on the outside, step number 6. Still got this big 4 on the outside. Okay, when I'm going to find the antiderivative of u to the 3 halves, we need to add 1 to my exponent. What is 3 halves plus another 1? 5 halves. Okay, and then don't we need to divide by that number? What is the same thing as dividing by 5 over 2? Multiplying by 2 over 5. There you go. Y'all, I'm going to leave that 4 on the very outside because that 4 is going to do, that 4 is on the whole thing here, okay? Minus 5, because there's a 5 there. Remember, when we're finding the antiderivative, we're going to add 1 to that exponent. What is 1 half plus another 1? 3 halves, okay? And then we have to divide by 3 halves. But dividing by 3 halves is the same thing as multiplying by 2/3, okay? We'll worry about the plus c in a little bit, y'all. Okay. All right, my step number 7, almost done. I'm going to leave that 4 out there. And now what I'm going to do is I'm going to leave my 2 alone. What did we start off with as our u? U was equal to x plus 5. Okay, so right here, y'all, I'm going to put x plus 5 to the power 5 halves over 5 minus, remember, I was really multiplying here. 5 times 2 is 10. U again is x plus 5 to the power 3 halves all over 3. Okay. And then finally, my step number 8, y'all, I'm going to go ahead and distribute that 4 to those pieces. So that's going to give me an 8. X plus 5 to the power 5 halves over 5 minus, what is that, 40? X plus 5 to the 3 halves all over 3. And then at the very end, don't forget, plus. And so again, you know, when I enter this into my open app, all I'm really going to plug in is this piece right here because they left that little plus B out there on the outside. So this problem here, y'all, was a little bit different in that when we started off with our substitution, we had to kind of do some additional manipulation. I'll get you in a second, John. We had to do some additional manipulation because if I let this be equal to my u and then my du happened to be my dx, we would come back and we'd say, look, that's going to be the square root of u, and here's my dx, and I don't have to worry too much about the constant because we can fix that, but we have that additional x in there. So if we have that additional x, let's go ahead and solve for x, rewrite it, and now we have a bunch of powers of u. John, you got a question for me?
Sure, when you have something like R3 hat, that's like saying you want twice the root, right?
No, that's saying you're going to find the square root and then you're going to cube it. So the denominator is telling you what root you're taking. The numerator is telling you what power you're going to raise it to. So like right here, this tells me I'm going to take the square root of x plus 5, and then I'm going to raise it to the 5th. This is saying I'm going to take the square root of x plus 5, and then I'm going to raise it to the 3rd.
So it was like if you find the third would be 1/3.
There you go. There you go.
I wasn't sure.
Okay, so take a look here, y'all. We're going to do the same type of process. Now we're going to evaluate a definite integral. So, y'all, remember indefinite integrals? Now, indefinite integrals, y'all, the answer we come up with is an actual numerical value because we then substitute those numbers in, right? So again, but look, I'm still going to do substitution here, y'all, and I'm still going to do my same process. So look, y'all, number one, remember when I told y'all, when you're doing these problems, you want to let your u be what I call like the inside function. So look at inside the square root. What do you see? 2x plus 4. So step number two, my du dx is going to be equal to, what's the derivative of 2x plus 4? Just 2. Step number three says, let's solve this for du. So that's going to be a 2 dx, okay? Step number four, we're going to divide both sides by 2 or multiply by a half. So we're going to get a 1/2 du is equal to a dx, right? Okay, y'all, so look, we're going to do the same thing here. I'm going to start integrating. So look, my step number 5, we're going to integrate. Y'all, I'm not going to worry about my limits just yet. I'm not going to worry about my lower limit, my upper limit. This is what we're going to do. We're going to say, look, dx is right here, dx is right here, but dx is the same thing as half of du. So I'm going to put my 1/2 on the outside. I'll leave my du right there. Okay. This 2x plus 4 is the same thing as our u, and since it's the square root, isn't that the same thing as u to the power 1/2? Okay, that's my step number 5. So now, my step number 6, 1/2, we need to find the antiderivative of u to the 1/2 with respect to u. So we need to figure out, what do I take the derivative of so that I get u to the 1/2? What do we do with our exponent? We add 1 to it, right? Okay. Does anybody remember what is 1/2 plus 1? 3/2, right? Good. And then, y'all, we need to divide by 3/2, but dividing by 3/2 is the same thing as multiplying by. So look, here's my 2, here's my 3. Okay. We're almost done, y'all. Step number 7. Let's go ahead and simplify. First off, do you guys agree that these 2's will cancel? So we're going to have a 1/3. Okay, now, u. We started off by saying u was what number? So we're going to call this 2x plus 4 to the power 3/2. Okay. I want you to notice, y'all, I'm not writing the plus c because this is a definite integral. When we're doing a definite integral, y'all, we're going to evaluate this from 1 to 0. Remember what that means. That means I'm going to come back 1/3, and everywhere we have an x, we're going to plug in a 1, and then we're going to do it again, and everywhere we have an x, we're going to plug in a 0, and we're going to subtract those numbers. So look, 1/3. Okay, let's plug in a 1. 2 times 1? 2. Plus 4? 6. So 6 to the 3/2 minus, we're going to plug in a 0. 2 times 0? 0. 0 plus 4? To the power 3/2. Okay. Now, y'all, John asked me a little while ago, what does the power 3/2 mean? It means we're going to take the square root of the number, but then we're going to raise it to the 3rd power. Okay. Well, I know what the square root of 4 is, right? The square root of 4 is what? 2. What's 2 to the 3rd? 8, right? Yeah, step number 8. 1/3. Okay. So 4 to the 3/2. Everybody agrees to number 8 because it's the square root of 4, and then you got to cube it, so that's going to give me 8. What about 6 to the 3/2? Do you know what the square root of 6 is?
No.
No. Okay. Neither do I. There's my answer. Can't do 6 to the 3/2 because it's not a rational number, right? It's one of those irrational numbers. So I would leave it right there. Can you guys? Do you have to do the 4 to the 3/2? I mean, you might be able to leave it as it is, but you know, if I can do it, I guess I will. But that's how I do definite integrals, right? I do the same thing. I don't worry about the plus c. Remember, y'all, definite integrals is telling me I'm going to get an actual numerical value. So notice we have a numerical value here compared to, something that looks like this, right? Okay, so look, we got a couple more. 1, 2, 3. We got 3 more to do. Okay, we're trucking along here. Easy breezy cover girl. Are they getting better, y'all? Yeah? Okay, good. That's what I was hoping for. That's why this section, y'all, we're only doing the one section a day. But they're repetitive. You know what I mean? There's like a process in how you're doing this. So remember, y'all, my step number 1 is what are we going to let our u be equal to? And remember what I said. Think about it as your inside function. What is inside? There you go. Okay, step number 2, my du dx is, what's the derivative of 6x plus 5? Just 6, right? Okay, step number 3, let's solve for du. Okay. Now, I want you to take a look at what I have here, y'all. We have a du equals 6 dx. Well, I see my dx right here. I don't have a 6. I really have a what? A 24. So, yo, before we were always dividing by something so that we could make what we have look kind of like what we have here. But I don't need to divide. I actually need to multiply. What do I need to multiply 6 by so that I get 24? 4. So look, y'all, 4 du is going to give me 24 dx, right? A little different, right? Gotta put attentions, right? In Spanish, pon atención. In English, put attention. Okay, so look, y'all, here's my 24 dx right there. Okay, that's the same thing as my 4 and my du, right? Okay. Inside, we have a 6x plus 5, but hey, we were calling that u, but it's u to what power? Third. Okay. All right, y'all. Now we can start integrating. So look, I'm going to leave that 4 alone because it's there. Y'all remember what we're supposed to do with our exponent? Add 1. So that's u to the 4th, and we divide by that same number, right? Okay. Y'all, I'm going to worry about my limits in a second, okay? Step number 7, let's simplify what we can and substitute. Do you guys agree that these 4s will cancel? Okay, remember what we started off with? We started off with u being equal to, 6x plus 5. That's all being raised to the 4th. And now, again, we can go ahead and use our limits. So our limits here go from negative 0.5 to 1. So negative 0.5 to 1. Okay. Step number 8, you guys, we're going to evaluate. Okay. So remember what I'm going to do. The first thing I'm going to do, everywhere I have the letter x, I'm going to plug in what number? 1. Okay. Question. 6 times 1? 6. Plus 5? Okay. 11 to the 4th power. Minus, because there's always subtract. Y'all, does anybody know what 6 times negative 0.5 is? What's half of negative 3? What's negative 3 plus 5? 2 to the 4th. Okay. And now at this stage, I'd go ahead and just get out my calculator. First time easy today. Let's see. What's 11 to the 4th minus 2 to the 4th? Probably something really big. 14,625. And we got it. Ooh. There you go. All right, so y'all, look, let's finish up 5.5, and then I'll give you a heads up, y'all, of what we're doing next week, okay? So look, we just got 2 last problems to do, and the last one is true or false. Hey, we know that we got a 50-50 chance of getting it right? If we just guess, right? We know we need.
Next question.
Yeah, just keep playing with it till it works out, right? Okay, so look, one more substitution type problem, definite integral, and then we'll figure out this true or false question in a second. Step number 1, very good. It's going to be our inside function. John says 3t. Okay. du, y'all, in this case, dt, right? Because that's the letter that we have. So I don't want to say du dx because I don't have x. I got t. What's the derivative of 3t? Just 3. Very good. Step number 3, let's get our du by itself. So it's going to be 3 dt. Okay. Y'all, again, we're going to do a little stare and compare. First thing I see here, hey, I have a dt. There's my dt. I don't have the 3. So let's multiply by 1/3 or divide it by 3. Okay. Excuse me. Step number 5. Step number 5, what we're going to do now, we're going to go ahead and see if we can write our integral. I'm not going to worry about limits just yet, y'all. Okay, let's see. That dt is the same thing as 1/3 du. So I'm going to leave my 1/3 out here. I'll put my du right there. Okay. And we have the sine of 3t. So that's really the sine of u, isn't it? Okay. So now I need to figure out what is the antiderivative of the sine of u. So remember what that means. I'm asking myself here, what do I need to take the derivative of so I get a sine u? So yeah, y'all, if I come back over here, let's see. I know the derivative of cosine gives me a negative sign. So what's the derivative of a negative cosine give me a positive sign? Right? Okay, so look, let me come back over here, and we're going to say this is really going to be a negative cosine of u. Okay. Alrighty. Step number 7, y'all. I'm going to go ahead. I'm actually going to bring that negative outside. So it looks like a negative, 1/3. Cosine of, we're going to go ahead and resubstitute. What did we say our u was? 3t. Okay. And we're going to evaluate that from 0 to pi over 3. Okay. Step number 8, here is my negative 1/3. Okay. Now, we're going to do some plugging in. Y'all, first time we do this, we're going to plug in this guy right in here. Okay. I'm going to ask you a question. What's going to happen with this 3 and that 3? They're going to cancel out. So we're asking ourselves, what is the cosine of? Okay. So if you don't remember, that's okay. Make sure you're in radians. Yeah, let's find the cosine of pi. Right there. And it is -1. So I'm going to put a -1 right here. Okay. All right. Now I'm going to do the same thing, but I'm going to plug in 0. What is the cosine? 3 times 0 is still 0. What is the cosine of 0? It is 1. So -1, right? So I'm subtracting. All right. So isn't this a negative 1/3 times -1 minus 1 is a -2? And what is negative? Isn't it -1 minus 1? Okay, so now what is -1/3 times -2? There you go. And here is my answer, y'all. Positive 2. Okay. All it is, y'all, plug and chug type stuff, right? We're doing that substitution type thing. Okay. Alrighty, let's do the very last problem that we got to do. Okay, here we go. True or false? If we were to let u be equal to 4 minus x squared, would we get this piece? Now, y'all, right now, when we've been doing our our definite integrals, I said, look, let's not worry about the limits until we're done, right? Okay, let's do this like we would do any problem. Look what they're telling me. They're telling me u is going to be 4 minus x squared, right? I'm going to follow the same steps we've been doing so far. What would my du dx look like? What's the derivative of this expression? Very good, -2x. Okay, step number 3 says, let's solve for du. So wouldn't that be a negative 2x dx? Okay. Step number 4, y'all. Step number 4 is when I start to write my integral. So look, we're going to integrate. Negative 2x dx. Hey, that's the same thing as my du, isn't it? So I'm going to put a du. Y'all agree that I can think about this as 1 over 4 minus x squared, right? And so that's going to be 1 over u. So far, so good? Okay. Now, I want you to notice something here, y'all. Look at the limits that we used to have before, and look at the limits that they have now. The way they're getting those limits, so let me do this over here on the side, and we're going to call it, that's not how you spell finding anymore. Finding Nemo, right? Finding limits. Okay. What was the bottom limit that we used to have? 0. Okay, guys, that means that x is equal to 0 because this integral involves the letter x. So if the first one was x equals 0, then what I'm going to do is I'm going to come back to my problem here, and everywhere we have an x, we're going to plug in a 0. So 0 squared is still 0, so that bottom limit, y'all, is going to be a 4 because it's 4 minus 0 squared. And so look, this number here is going to jump down to a 4. Okay. My step number 2, what was my x number up here? Okay, so I'm going to come back to this part here. I'm going to go u equals 4 minus 4 squared. So that is 4 minus 4 squared is 16. And 4 minus 16 is a negative 12. Did we get the same thing? Okay. So y'all, right here, we're going to select. Let me tell you what we basically did here, y'all. All we're doing here, let me see. I'm going to ask you guys a question. I don't know if you remember or not. If I wanted to find the actual answer of this problem, okay, so this is kind of like an extra step, extra. Okay. Does anybody remember? And yet, y'all, this is one of those kind of special formula ones. Does anybody know what the antiderivative of 1 over u is? And if you don't, that's okay. I'm going to come back this way. I'm going to see if it's in here. It is. I just need to see where it is. Let me scroll, let me scroll, let me scroll. Let's see. It should be, I thought it was in here. Yeah, it's here. It's just here we go. It was doing like the logarithmic differentiation. Here we go. So look, if the derivative of y with respect to x is equal to 1 over x, then my antiderivative would be what? Natural log of x. Okay. So what we would be doing at this step, y'all, is we'd be saying, in this case, the antiderivative here would be the natural log of u. Instead of us having to go back and substitute that value u in, we can go ahead and evaluate it now from negative 12 to 4. And before, what we would do is we'd say, look, when we get to this step, it's the natural log of u, we'd come back and we'd plug in that for the u, right? We would say, okay, look, it's going to be the natural log of 4 minus x squared, and then we would do this from 0 to 4, right? What we're doing now is we're saying, instead of us doing that, we can just do it like this. So that would be the natural log of negative 12 minus the natural log of 4. And that's, in essence, what we would end up with, right? And that's all. And look, guys, if you were to plug in the 4 right here, isn't 4 squared 16? And 4 minus 16 is negative 12. And if I were to plug in the 0 right here, 0 squared is 0. 4 minus 0 is still 4. So we're just saying that you can do it like that. You don't have to go back and re-plug in that x, because now we have new limits. We have limits involving u. It's just another way of doing the problem, but that's all that it's basically saying, is instead of going back and resubstituting that value, you can do it with u, as long as you define as long as you get new limits. You can't use the same numbers that I had over here before, because here I was dealing with the letter x. Here I'm dealing with the letter u, and u is a function of x, right? So I need to find those new limits. That's all that problem is really saying. Okay.
So that's from 3 to 4.
Uh-huh.
If you multiply everything by negative 1/2, is that what you did? Or by 1/2?
No. All I did is saying, look, if it's, this is going to be, let's see, my 2x dx is the same thing as my du, right? So that's what I have right up here at the top. Isn't that my du? And then I have 1 over 4 minus x squared, but 4 minus x squared was the same thing as u, right? So I wrote it as 1 over u. And then all we did is we found our new limits. Better? Okay. All right, y'all. So look, let me go ahead and stop recording here. Let's see, come back this way.